Welcome back to Cosmos in a Pod, Space and Astronomy Series, Episode 4. Today we're diving into a realm that's fascinated us for centuries. Exoplanets.
Planets orbiting stars beyond our sun, right?
Yeah.
A field that's just exploded in recent years. It's really remarkable how we've gone from just speculating about these distant worlds to actually finding and studying them.
I know, it's incredible. Like when the first exoplanets were confirmed, it felt like sci-fi was becoming reality. But those early discoveries were just the beginning, right?
Yeah, definitely. In 1992, the first confirmed exoplanets,
They were orbiting a pulsar. That's a rapidly spinning dead star, right?
right, a pulsar, definitely an unexpected place to find planets. It really challenged our understanding of planet formation, like where could planets even form?
Yeah, but that discovery, it was like a prelude to a much bigger one a few years later, wasn't it?
Oh, absolutely.
51 Pegasi b.
Exactly. The first exoplanet found orbiting a sun-like star.
That was huge. It basically launched this whole field of research.
Yeah, it showed us that planets could exist around stars similar to our own, which meant, well, it raised the possibility that there could be other solar systems like ours out there. And the discoveries haven't stopped since.
Seriously, it seems like every time I check the news, there's another exoplanet.
Yeah.
Thousands have been found already, right?
Oh, yeah, over 5,000 confirmed exoplanets and counting, and the diversity is incredible.
Yeah.
We're talking massive gas giants, rocky worlds, planets with these crazy short orbits, and systems that look nothing like our own solar system.
Wow. So we're finding all these different types of planets, but the big question, the one that keeps everyone on the edge of their seats is, could any of these planets have life?
Right. That's the ultimate question, the driving force for many exoplanet researchers, the search for life beyond Earth. To even start answering that, though, we have to focus a bit. I mean, not all exoplanets are created equal when it comes to the possibility of life.
Right, right. It's got to be, the Goldilocks planets. Not too hot, not too cold, just right for liquid water, which is what the whole habitable zone thing is all about, isn't it?
Yeah, the habitable zone, that sweet spot around a star where conditions are just right for liquid water to exist on the surface. Because, at least as far as we know, liquid water is essential for life as we understand it.
Absolutely.
Yeah.
And we've found some promising candidates in that habitable zone, haven't we?
We have. There's Proxima Centauri b, for example. It's an Earth-sized planet orbiting, get this, Proxima Centauri, the closest star to our own. And it's right in the middle of that habitable zone. Just imagine a planet that could potentially have life right in our cosmic backyard.
It's almost too good to be true. But, I was reading that Proxima Centauri b might not be the paradise planet we're hoping for. It orbits a red dwarf star.
Yeah.
Which are known to be pretty volatile, right?
That's right. Red dwarf stars can have intense flares and radiation bursts. So Proxima Centauri b, even though it's technically in the habitable zone, it could have some really harsh conditions. Whether life as we know it could survive there, well, it's still a big unknown.
So maybe not the best spot for a second home then. But it's not the only potentially habitable planet, right? Wasn't there another system that really got people excited?
No, you're talking about the TRAPPIST-1 system.
Yeah, is that the one?
No, that one's remarkable. We're talking about a single star with seven Earth-sized planets orbiting it.
7. That's incredible.
Yeah.
What are the chances of finding that many planets around one star, let alone Earth-sized ones?
It's incredibly rare. But here's what makes it even more exciting. 3 of those 7 planets are within the habitable zone.
So we could potentially have 3 planets, all in one system, capable of supporting life. That's almost too much to process.
But hold on, how do we even know all this? I mean, these planets are light years away. It's not like we can just look through a telescope and see them, right?
You're absolutely right. Directly observing exoplanets, extremely challenging. They're incredibly faint compared to their host stars. Think of it as like trying to spot a firefly next to a huge spotlight.
Oh, wow. Yeah, that makes sense. So how do we even know they're there? It seems impossible. Well, astronomers are pretty clever. They've developed some really ingenious ways to indirectly detect these distant worlds. 2 of the most common methods are the transit method and the radial velocity method.
Okay, break those down for me. Let's start with the transit method. How does that work?
Okay, imagine you're looking at a streetlight and a tiny bug flies right in front of it.
Okay, I'm picturing it.
You'd probably notice a slight dip in the light's brightness, right?
Yeah.
As the bug passes by. The transit method works in a similar way. When a planet passes in front of its star, from our view here on Earth, it causes a tiny but detectable dip in the star's light.
So by measuring these tiny dips in starlight, astronomers can figure out if there's a planet orbiting that star. That's incredible.
Exactly. Not only can they confirm a planet's existence, they can also determine its size, its orbital period, even get some clues about its atmosphere based on how the light changes as it passes through.
Wow, that's amazing. What about the radial velocity method? How does that one work?
This one uses the subtle gravitational dance between a star and its planet. Basically, a planet's gravity tugs on its host star, causing the star to wobble ever so slightly.
Like a cosmic tug of war.
Perfect analogy. And by analyzing the star's light spectrum, astronomers can detect this wobble. The amount of wobble tells us about the planet's mass and its orbit.
Okay, so we can figure out a planet's size and mass using these indirect methods. That's impressive. But what about learning what's actually on these planets, like their atmospheres?
Now that's where things get even more interesting. When a planet transits its star, some of the starlight actually filters through the planet's atmosphere. It's like, imagine shining a flashlight through colored glass.
Oh, yeah.
The glass changes the color of the light, right? Similarly, a planet's atmosphere can leave its fingerprints on the starlight.
So by analyzing that filtered starlight, we can actually figure out what the planet's atmosphere is made of.
Exactly. Scientists can identify specific chemical signatures in the starlight that indicate the presence of things like, oh, water vapor, carbon dioxide, methane, and even oxygen. These chemical clues, we call them biosignatures.
Biosignatures, that's a great term. So these are like chemical hints that could tell us if a planet might have life on it, like a message from another world.
It really is like that. And with new powerful telescopes, like the James Webb Space Telescope, we can now study exoplanet atmospheres in incredible detail. It's totally revolutionizing our search for life beyond Earth.
This is all so incredible. It feels like we're right on the verge of unlocking some of the universe's biggest secrets. But, before we dive even deeper into that search for life, let's take a moment to think about what these biosignatures might be telling us and what it all means for our understanding of life itself.
And welcome back. We were talking about biosignatures, those chemical hints that could point to life on other planets. Really fascinating stuff.
Yeah, they got me thinking. It's amazing that we could detect signs of life light years away just by analyzing starlight. But are we limiting ourselves by looking for life as we know it?
That's a great question and a big debate right now in science. Our search is naturally biased toward what we're familiar with.
Right. Carbon-based life needs water, like Earth.
Exactly, because it's the only life we've ever found. But imagine life on other planets evolved under totally different conditions. What if it's not carbon-based?
Yeah. What if it thrives in environments we think of as extreme?
Exactly. Picture a planet with oceans of liquid methane instead of water, or organisms that love scorching heat or intense radiation. Life could take forms we can't even imagine.
It's mind-blowing. We could be missing out on totally new kinds of life because we're so focused on finding something like us out there.
Right. And that's why studying exoplanets is so important. It forces us to broaden our view, to rethink what life even means.
It's like we're redefining life itself. It's humbling and exciting at the same time. But let's get back to the search for life, even if it is familiar. What happens if we find evidence of life on an exoplanet? What would that mean?
Even finding microbial life would be huge. It would mean Earth isn't unique in having life, that the universe is teeming with potential for life.
It would change everything. Our whole view of our place in the cosmos would shift.
A complete paradigm shift for humanity. Philosophical debates, theological discussions, and a whole new wave of scientific exploration.
But what if we keep searching and find nothing? What if Earth really is alone in a vast, sterile universe? That's kind of a scary thought.
It is a possibility. And while disappointing at first, it would also raise some big questions. Why is Earth so special? How rare is intelligent life? It deepens the mystery of our existence.
So it's like either answer, finding life or not, leads to more questions. Like peeling back layers of an onion, there's always another layer underneath.
That's science. Every discovery opens up new questions. We may never have all the answers, but the search is what drives us.
I love that. The journey matters just as much as the destination. Speaking of, we've talked about the challenges and the incredible potential of exoplanet research. But what's next?
Well, we've found over 5,000 exoplanets, but that's probably just a tiny fraction of what's out there. Technology is advancing, so we'll detect even smaller planets, fainter ones, maybe even more Earth-like.
And with telescopes like James Webb, we're getting such detailed looks at exoplanet atmospheres so we can analyze those biosignatures even better.
Right. We might even find signs of active biological processes on other worlds.
Wow. It's incredible that we can do this. to study atmospheres light years away and maybe find evidence of life. It's science fiction coming true.
It really shows human ingenuity, our endless curiosity to understand the universe and our place in it.
Absolutely. But besides the search for life, studying exoplanets is helping us answer big questions about how planets form, how star systems evolve, and just the amazing variety of worlds out there.
We're always learning new things, challenging what we thought we knew, expanding our understanding of the cosmos.
We've focused a lot on the science, but there's also the wonder that exoplanets inspire, right?
Definitely. Just imagine out there billions of stars, and some might have planets with oceans, continents, maybe even civilizations looking up at their sky wondering if they're alone too.
It's both humbling and exciting. It makes you realize how vast and mysterious the universe is.
And how much more there is to discover.
Okay, as we wrap up this part of our deep dive, what are the key takeaways you want listeners to remember?
First, we're not alone in terms of planetary systems. Planets are everywhere, and the diversity we're seeing is beyond anything we could imagine.
And that within this vastness, there are planets that might be like Earth, with life as we know it, or maybe life as we haven't even dreamed of yet.
Exactly. Exoplanet research is changing how we see life, the universe, and ourselves. And it's just the beginning. New discoveries are happening all the time, pushing the limits of our knowledge.
Yeah, it's mind-blowing. It really feels like a new era of discovery. Who knows what's coming next?
Oh, the future of exoplanet research is wide open. We've got new missions being planned, telescopes are getting more powerful, and scientists, well, they're coming up with even more creative ways to study these distant worlds. We're really just getting started.
So for our listeners who want to learn more, what would you recommend? How can they dive deeper into all this?
Just stay curious. There's so much out there, online articles, videos. There are even citizen science projects where you can help analyze real data from exoplanets.
Oh, wow. That's awesome. Getting hands-on with the science is the best way to really appreciate it all.
Absolutely. And of course, don't forget to look up at the night sky. Every star you see could have planets orbiting it.
It's a humbling thought. We're part of something much bigger.
Much bigger, yeah.
Well, I think we've covered a lot today. Those early discoveries, the sheer variety of planets, the possibility of life beyond Earth. It's been quite a journey.
It really has. I hope our listeners enjoyed it.
I'm sure they did. To all our listeners out there, if this deep dive into exoplanets has sparked your curiosity, be sure to follow and subscribe to Cosmos in a Pot for more explorations of the universe. Until next time, keep looking up and keep exploring.